All right, so this is kind of part two of our area of a triangle examples series, mini series, very mini since it's just 2 videos long. We're going to look at area of a triangle when we're given the side and another side and the angle that's in between them. And that's really important. I've kind of put up our example here. It's very, you cannot use this formula unless you know the angle that is in between the two known sides. It has to be the one in between. So, like in this particular picture, this little green triangle here, if we knew this angle and then this side and this side, we could not use this formula. It would not work, right? So we have to know the included side, right? We have to know the one that's in between them. And so that's really important. After that, it's really simple. Now, you in your notes, if you're in my class, or otherwise, you probably already have this formula down and all of those things. And you'll notice I just kind of wrote one version of this formula. We know that this works for any size and any angles because this can be any triangle. This just like everything else in this lesson, in this unit, they don't have to be right triangles, and that's important that we keep all of that in mind. Excuse me. And so it can be any size. It can these letters could be we switched around to A and C and B, right? Or whatever else, right? So we've got the formula, we've got the triangle. All we got to do is to solve for the areas. We got to stick numbers into the formula, and it's that simple. This is as easy, probably even easier than Heron's formula. Both of them kind of look a lot scarier than they are in practice. They're not that hard at all. So we're going to put 1/2 times 35 times 33. Right? Now, the order doesn't matter here. Just like in our Heron's formula example, multiplication is commutative, so you can rearrange it. So it could be C times B or B times C. It doesn't actually matter. Times the sine of the angle. Now, you'll want to make sure and be careful when you're doing this that you check to make sure that your calculator's in the right units. A lot of time, most of the time, we're going to be doing these in degrees, but if our angle is given in radians, then you're going to need to be able to use radians there. Let me clear this mess out real quick. And on this particular calculator, it's different depending on which calculator you're actually using. I'll go ahead and pull up another calculator here as well. Let me actually pause this recording so I can do that because I forgot. So these are kind of the two kinds of calculators that I illustrate in videos. If you've not seen this before, my preference is this HP. The calculator's better, the emulator's better. You can get the emulator for free on mobile and on computer. But the TI-84, whether it's a color edition like this shown here, or the excuse me, or the regular one, or the regular TI-84 plus it like this one here, either one of those are still probably the most popular calculators anywhere in the US, especially in public schools, and even just like calculators you're just going to go buy at the store and whatever else. And so I'm going to show you how to change this between radians and degrees in both of them. There's a lot more words, but I'm kind of filming at this in the middle of stuff. Both of these two calculators have an indicator that shows you what mode they're in just on the screen at the beginning. And this is one thing that's nicer in the 84, and that is it shows you up here in this right now as in radians. It says radians right there. So on the 84, to switch it to degrees, we hit mode, and then we go down to degree. I think on this emulator, oh no, I can't, just kidding. Emulator works like you'd expect. And then you go over to degree and you hit enter. And then to get out of this mess, you hit second and quit. So now see we're in degree mode, right? So we're going to put that guy to sleep. Now the HP on the HP prime, it also indicates whether it's in degrees or radians. It's actually in radians, and it's harder to. It's a symbol thing, which is nice because it gives us more screen real estate for other stuff. But we have to click up here in the top right, and if you have one of these guys, it's a touch screen. And if you have the emulator, it's obviously it's also a touch screen, or you can click it with your mouse. And radians is the one with pi in it, and degrees the one with the degree symbol. So see, now we say angle just degrees, which is what we want for this problem. So for this problem, we can just punch all this mess in, right? We can do a half, do 1 divided by 2. Make sure if you're on a graphing calculator, you put over to get out of the fraction or whatever. You can use your fraction button. You can use 0.5, whatever you want to do. And then times 35 times 33 times the sine of 26. We don't have to type degrees because we're in degrees. And then we hit enter. And we get that the area of this triangle is approximately equal to 253.16. 200 and was it 253? Is that what we had? Yeah, 253, 253.16. Units are centimeters, and it's area, so it's centimeters squared. And that's all there is to using that. I said it in great detail towards the beginning of this video, but it's really important to note that if we have a triangle like this one, where we know an angle over here, and then we know a side over here, and then we know a side over there, we cannot use this formula in order to do this problem. We'd have to go about it some other way. So that is it for this thing. We will see you in the next one. Goodbye.